Well, welcome everybody to our demo of a potential digital twin solution that we've been discussing since this morning and throughout the day. I'd like to thank all of the folks who have kind of built up to this point throughout the day, and we've had a bunch of great presentations, and starting yesterday with Eric Chappell's presentation on BIM, and this morning with Dennis's talk on SBS and their direction as far as BIM's going, and just for the record, every one of the guys that have been talking and all the stuff we've been talking about is all 100% valid. In my opinion, if we don't start moving in the direction of BIM modeling and in the direction of, the 3D, 4D, 5D, 7D, 8D, however many Ds we got these days. We're just simply not taking advantage of where we're at and what we can do. To that end, I was, working with Trevor off and on throughout this as we prepared for the solution, and we were looking at this digital twin thing. And I'll be honest, when I first started thinking about it, I was thinking, well, what practicality is there from the transmission space? What good is a digital twin of a substation? What good is a digital twin of a transmission line? And I didn't get it at first until I actually started doing something with it. And then once we started actually putting data to it, we realized really, really quickly just the general practical value of having a twin of what we do. And it came about so fast that it was like, okay, why didn't we think of this before? And somebody was saying yesterday or this morning, BIM is kind of an advanced topic. Yeah, after doing this work, I don't think it really is an advanced topic. I think it's really just the next logical step that we need to take especially from the utility perspective. We do all of the stuff that we need to take our BIM models all the way through, 7D or 8D is, the eighth dimension of BIM. We just do it in silos today. We do it, we've got our planning over here in their group, and we've got our, estimating in their group, and then we've got design in its group, and then we've got operations in a group, and we've got maintenance in a group, and everybody does stuff, with a substation or with a transmission line, but we don't do it together, and we don't share our data. And if we could just get past that point and say, hey, this is our data, it's our data globally across the whole footprint, let's all intermingle and all join forces here, then it's a really simple and easy logical leap to go from a bunch of drawings to, a bunch of single lines to a bunch of CAPE data, for protection and controls, limits and all that kind of stuff. It's all a really simple step to go from, the overall spread out version of that data into one unified model that we could all use and we could all do stuff with. And I'm going to show you some pretty practical things that we could do here in this demo app that Trevor and I put together. Trevor did the front end stuff. The front end stuff is actually kind of a hard concept for me. It makes my head hurt, really. I'm more of a back end person, so much thanks to Trevor on the React side and the JavaScript side. My expertise is really in just databases and infrastructure and wiring this stuff up. So thank you very much, Trevor.
Hey, we made a good team, Sean. I have no idea how you did the back end. So perfect team.
Well, I try to hide that so that I have that in my pocket. I didn't mean to say that out loud, but I did anyway. All right. So we started looking at this at Southern Company because we have a group at Southern Company who does what's called condition-based maintenance. And the condition-based maintenance group, they get, they have sensors on all of the substations, not all of them, but a large amount of sensor data on major equipment out in substations. So transformers will have sometimes 7, 8, 9, 10 sensors on the transformers. Yeah, sensors on the relays and sensors on the breakers, the major equipment, the stuff we buy, a lot of them have sensors, and they just capture that data, and they continue to capture that data on, 30-second cycles, every minute, every 5 minutes, whatever they need to capture for that particular sensor reading, right? Put it in a big database. Could be Oracle, could be SQL Server, could be, some other vendor. But they put it in a database, and then they spend a lot of time and a lot of energy essentially pulling that data into spreadsheets and then do an analysis on it to try to figure out trends. So if you think about it from what we were trying to do, or from what they're trying to do, they capture a bunch of data, they pull it into a spreadsheet, and they're trying to figure out things like, okay, this transformer has a top oil sensor, and I want to make sure that the temperatures in Celsius for that sensor fall within a given range. If they're too hot, then our cooling's not working on our transformer. If they're too low, that's a problem as well. If we have voltage regulation going up and down, something like that, that could cause outages and all that stuff. So what we're trying to decide is, given that data, do we need to do something with that data and schedule maintenance and get out there and do something with the equipment? Because if we can catch the equipment before it faults, then we don't have an outage, or we can schedule an outage and do it in the evening and not have a whole bunch of people lose power. But if our equipment schedules an outage for us, which happens quite frequently, if you're not doing the maintenance, then that's a problem. So CBM gives us the ability to capture that and do it, but we don't want to have to do that in spreadsheets. We don't want to have to do that after the fact. We would prefer to do it as close to real time as possible. And since this data is simple IoT data, doesn't really have any identifying stuff, doesn't really have the ability for us to toggle states on and off, doesn't really give us the ability to do anything to the equipment other than see it, it's safe to use. So given that, sorry, I'm getting like 3 phone calls from the same number over and over, and I'm not sure why. Given all that, we have captured, or I went and pulled a bunch of data into a SQL database, and we've configured it such that we have sensors on our equipment on some substation models that we've pulled in, and we're going to show some of the sensor data. So before I go over, or while I'm going over here and pulling this up, do we have any questions thus far? Have I gone over anybody's head? Anybody have any burning questions they'd like me to answer now?
Yeah, Sean, I'll jump in here. We wanted this to be similar to like the roundtables and some of the more interactive events we've had at live conferences. So I believe everyone can unmute their line, everyone can turn on their camera. And if anybody wants to share any of that stuff, we can. So please, feel free to ask a question or put in the chat, and I'll watch for them, Sean, as you're demoing.
Okay. All right. So what we've done here is we've used, I think many of you have probably heard Autodesk Forge mentioned a few times this week. What we have is I have 4 substations that I put in what's called an OSS bucket. These are document management buckets on Autodesk Forge platform. Initially, I wanted to start off with BIM 360, but with BIM 360, that requires a login. It's kind of controlled by internal, which is good. Obviously, we don't want just anybody to bust into BIM 360 and start taking assets or looking at our stuff, but it was a limiting factor for being able to demo what we did. So took the models, pulled them into OSS, which is a Forge document management system, which is not a document management system. It's fundamental to document management. And coincidentally, BIM 360 is built upon Autodesk Forge OSS API. So I'm going to pull up a model here. I'm going to pull up Airport Road first. So Airport Road is where I focused my attention this week because I had some data and I can show you on this model how this data works. And we're doing a live demo here, which is kind of a taboo thing to do in a webinar because things go wrong in live demos, but hopefully this is simplistic enough that things are going to be okay. So this is you know, coming in on the high side, two points on the high side, they come in this transformer and they go out on the low side here. I think these are 6 regulators here and some breakers in the middle and a transformer control house over here, right? Fairly simple distribution substation. The names have been changed to protect the innocent. And this isn't using actual, data that's in the, inside our network. This is really kind of a prototype substation that we have. So let me enable my sensor data. You'll notice immediately that I get some graphs over here and I have some sensors pop up here. These are just short graphics that we pull in using Forge's DataViz API, which just came out of beta in the last few weeks or so. So down here in this particular grid, I've kind of aggregated all of the data that I'm getting from these sensors. Now, one of these doesn't have any data, so we'll turn it off anyway. But as I click on a node, we can see some of the data feeds in the grid turn off and on. And so what I'm left here with is breaker 6 amps. And if I highlight any of these data points here, we can see the actual reading. So I got a reading from March 22nd, where the amperage was 46.4. Go back down here and hover over one of these guys. Come on, baby. There's a lot of data in that one little point there, so it takes a second to pick it up. But the data that I'm pulling in, there's about 10,000 data points that I pulled in over these 3 days for this particular breaker. So we go from 40 something up on the high side, 22.4 down here on the low end for this particular reading. I'll turn that one off and turn the transformer oil back on. And so here we can look at some temperatures. And this reading was particularly interesting to me because this is a top oil temperature of a substation, not this substation, but it's actual substation data that we pulled in for transformer here in Alabama. And the temperature fluctuates from 31 and some change Celsius on the morning of March 22nd. And it jumps all the way up here to 39.16, and that's in Celsius. So Trevor, who they use Celsius up there in Canada, he might could pull the number off his top. I had to look it up. That was like a 20 in Fahrenheit, between the numbers, or maybe. But what was interesting, I went and actually looked at their data at that was happening. And the data showed that on that day, we actually had a 20-degree jump in temperature. So we went from 40 degrees morning to close to 80 degrees that afternoon one day. So the temperature was, that sensor's actually, hey, there's an ambient difference outside of close to 20 degrees, and it's actually picking up in the, the oil temperature of the transformer. So the sensor data that we're coming in and reading is actually pretty accurate. And if I want to, or is pretty indicative of what's going on. If I want to drill into just that sensor, I can click that particular sensor on my map here and see that data as it comes in. And if I was pulling a real-time feed, which I'm not, because we don't have that real-time data available to us right now in this model, we just have a snapshot of the data for 3 days. But let's assume that we have a direct feed coming from our real-time system into our cloud-based system here, then we could refresh that data and actually read that time and even set our limits up here and change the graphics here to show high, low, whatnot, actually modify the graphics within the model to pick up different things. And I can show other sensor values as well. So I go here and pick on this regulator. Actually, I called it a breaker and put breaker 6 amps on here, but you can kind of get the idea of what we're trying to accomplish here, right? So any questions now? All right. So
Yeah,
some of the, go ahead.
I was just going to mention real quick, is that a something that's triggered, or maybe you're at the very beginning stages, but is your thought that you would have certain values in here that if it exceeded a certain value, you would get something that pops up on your mobile device or something that would say, hey, and you just click on that link, and I guess something like this would pop up and identify the equipment and maybe even see the 3D model along with it.
Absolutely. That is exactly what we're trying to accomplish. And actually, at the very beginning of this, if you guys can see the chat, you can go to the top of the chat and click on that link, and you'll go to this website right here. It's actually out there on the cloud, and you can click on it. I welcome you to click on it with whatever device you have available. You got an Android smartphone, use it. You got an iPhone, use it. iPad, use it. Linux machine. I might be the only nerd on here that's running Linux, but if you got Linux, it works on that too. Go ahead and click on that link and poke around on the models, because you're going to find that all of this stuff works on any modern browser. I think the only browser that I haven't had work, 100% out of the gate has been the older Internet Explorer browser. Any modern browser, this just works on, and it works almost flawlessly. So I've been really, really pleased with the support that has been put into this particular framework and this particular tool. This is all just standard web stuff. This is JavaScript and HTML, CSS. This is the language of the web. So typical web developer folks can do this kind of work. So some of the neat features.
Sean, I have a question too. Are you also warehousing this data so you can start looking, and I realize you're just doing initial proof of concept, but for the longer term, are you looking at warehousing options so you can really look historically at different cycles and those kinds of things and how they impact long-term asset performance?
Absolutely. So at Southern Company, we're already warehousing the data. That was what I was talking about before. We're already capturing the data and have been capturing it for some time. We've just been capturing it in kind of a tower over in the CDM area. And we haven't really been using the data except to, pull it up in a spreadsheet and do some reports and stuff on it. Not to say that the CBM folks haven't been doing good work. They really have. They've been using it, but they haven't had a visual mechanism to do this with. They didn't, in a lot of cases, know this capability even existed. So, being able to show this to people and say, hey, you've got all this data. You've got, data for years and years. Let us pull it in and show you historically what your equipment's been behaving like, and show it to you visually so that you can actually, put this in front of somebody who doesn't want to stare at a spreadsheet and, physically, use my time scrubber here and scrub across the values and actually see what the system's doing, right? But every bit of that's capable within the system. We were asked, we did a demo last week with some of our operations and maintenance folks, and they asked a pretty interesting question. So given that we've got this, let me toggle this sensor back on right here. So given that we've got these temperature fluctuations on this particular transformer, and it's going up and down, I don't know, but I'm not an engineer, so I can't tell you if those are good or bad values. I assume they're good because, we haven't heard of an outage or a transformer catching on fire or anything. So I assume they're well within limits, right? But let's assume that they're approaching the top and lower limits. This transformer here is indicating that it needs service, if that is the true assumption, right? So if it's indicating that it has service, can I get equipment into the substation to do maintenance on it? Like if I need to lift that transformer up with a crane or something like that, do I have enough clearance inside my substation to do that? Well, with a model that's, drawn to scale, I can simply measure and tell you right off the bat. So I see my gate right here. I'm going to click between my gate and I can say, okay, the widest crane I'm going to get is going to be 21 foot. So if I can get something that's, not any wider than 21 feet, I'm good. And then I'm going to measure and say, okay, what's my distance to this this conduit here is 64 feet. And here, let's say here to here, 55 feet. Then I know that I've got 55 foot here and 64 feet here. And I'm not going to my coal or my underground here with a, if I get here, right? Or I know where conduit is, so I avoid it with my equipment. And this, as far as your standard box for viewer behavior, anything special, Trevor and I didn't do anything to the measurement, model explosion and stuff like that. That comes with that's out of the box behavior. Here starts sort of where we start pulling in sensor. So I'm going to
Sean,
switch to a different model.
Yeah, sorry, buddy. That's a great point there when you're, the Autodesk Forge piece of this, we're using this for our content piece too. Like, to be able to consolidate different models and information, we can take up to 65 different file formats into that viewer. So it, thanks to Forge, we can pull in, step files, IGES files, MicroStation, all kinds of different stuff to kind of merge it together into one model. So if you got some different vendor data that you want to show in there, you could easily pull it in with Forge too. Sorry, Sean.
No problem, man. No problem. So we went a little bit of a step further. So this particular station, I didn't have any data for it, but I wanted to go ahead and show you the example of adding a sensor. So this is a little bit of a backwards example because the way I think we should really probably do it is say, okay, on the data side, we've purchased a sensor, we've got a data feed, but we don't have a visual representation of the sensor in our model. So let's go to the model and we're going to add a device and I'm going to say, okay, that's on this regulator here. And then I'm going to click and I'm going to call this regulator 6. And the device model, the sensor model, I'm going to say is a ABB MegaMaster. I just made this stuff up. And we actually do want to measure volts on a regulator. So I'm going to submit it, close this. And hopefully if everything worked, when I re-enable my sensor data, I now have this sensor and it's ready to go. And if I have this particular ID, this long number right here in my database, I would immediately start seeing sensor data come in for that particular device. So I wanted the ability to show that we can add sensors on the fly, add it from the user interface. So we have people that are non-engineers or people who are just out in the field. They know that there's sensor there. They see that sensor. They want to make sure that they've got the data feed. Maybe they can wire it up right there on their device, iPad or whatnot, and pull it up right there.
Hey, Sean, we got a question here in the chat.
Okay.
It is, let's see, I think from Nate. He said, if you were to make an update to a model, such as adding a new bay, would you have to reinsert the sensor tags into the model viewer? So I think, Nate, basically you're asking if the model or assembly changes, do you have to redo all the sensors?
I think the answer to that is no. This data, the sensor data information is actually stored in a SQL database, and it's stored with XYZ coordinates that are mappable to the geometry of this view. So if you change the bay or whatnot, you're not going to have to reinsert the sensor. Well, actually, you might have to move it. So that's actually really something that we'd need to look at, right? Right now, we don't have the capability to update that sensor, I think is the real answer. If you did update the model and add a new bay, obviously that might change where that sensor lives. So we'd want the ability to move it. So maybe we would want to delete it or update it. And I just haven't wired those controls up yet, but that would be something that we could do, certainly.
Yeah, good answer, Sean. I think one of Nate's other question here is, are the tags linked to the individual items in the model? So if you use that explode feature in the viewer and drag the model so all the components explode, the sprite's not going to move with it.
No, I don't think so.
And that's okay. So
we can try it.
Yeah, it's so yeah, you see that. So what we did here is in Forge, to place anything, it needs a hit test against an XYZ of the world coordinate in the viewer, which is geek speak, to find out that the viewer doesn't have a Z coordinate on the browser page. So we ran a hit test and placed the sprite, but there is a tool extension for Forge called Snappy that allows you to snap to a vertex on a model. So that's what I think we'd use in the future, Sean. We just haven't had a chance to test it, right? So I think if we snapped it to a vertex, it would follow. So
yeah,
future test.
Another thing that happened today, right? So my first presentation for the technology committee today had AEP in there, and they were talking about SIM, Common Information Model, and some of the stuff that they want to do at AEP to link everything together. So really, in a nutshell, and I hope somebody from AEP is in the meeting. I can't really see all of the attendees. So if I say something here that's wrong and you're in here, please correct me. But kind of in a nutshell, with SIM is kind of a definition language that says if we all start speaking SIM, we can link all of our stuff together in such a way that one ID, so if I have an ID that points to this regulator, that ID points to this regulator in this model. It also points to this regulator if it lives in a maintenance system inside my system. It also points to this regulator if it lives in a procurement system that lives inside my operating company. It also points to this if it lives in CAPE and I need to add wiring or something like that. It shows its point inside of a single line or a 3-line or whatnot, but it uses the exact same ID regardless of the system that I'm in. And so if we really truly embrace a language or a unified identification model, something like SIM, then it would be very easy to take this sensor and say this sensor is attached to this guy, and this guy lives in this model, and oh, by the way, this guy is also in the real-time data with the exact same ID, and oh, by the way, if we need to order another one, this is the model, and we know it's the model because it's the same ID that's in the ordering system, et cetera, et cetera. So having global IDs that really truly identify one piece of equipment globally across the entirety of my footprint, or even in its entirety across the whole, grid, United States grid, North American grid, et cetera, is well within the bounds of what we can do. And you can tie that sensor and even share that data if you really wanted to. So this could be a huge point to say that, not just within what we do at one individual utility, but all across the board. We can have one unified model to identify this stuff. And the SIM unified modeling language that AEP talked about is really a compelling answer to that.
Yeah. Hey, Sean, I'll just comment on that too. I mentioned global IDs earlier today when I presented, and also identified the concept of the digital thread. And those are really what tie a lot of that together. We're fully supportive of SIM. We also have been watching it evolve over the last 10 years. So while we have the global IDing technology in place, putting that into the SIM model is something that we're really comfortable doing as product developers. I think that is one of those topics as a committee, it would be really good to work through in terms of what you'd like to see there from us, because that is not a big leap. And we, these are all things we follow. And we're really looking for those use cases where we could start applying that. SIM is interesting. It's evolved a lot. It's also very voluminous. It's a really big format, so to speak. So internal to the product, we've not been using it. Most vendors don't. They present SIM kind of on the boundary of their product interfaces. So let's keep that one in mind. And if we need to get more smart SBS people involved, we're happy to do so.
I think there's some really a lot of value in that regard. Another of the questions that we were asked was, how do I take this model? Let me show this model back again. How do I take this substation model and plug it into my GIS system, and then plug it into my operations system such that on my GIS system, I can actually show my electrical limits, the electrical limits of this substation in my operations and in my GIS system. And
Yeah.
SIM provides a mechanism for that, right? Because you can map, the actual circuits and single lines and the wires and the jumpers and all that to actual equipment here, and then wire it into a global single line or 3-line or whatever.
Yeah, absolutely. And that's an area, again, where we're doing similar things on the distribution side right now with interoperability between the AutoCAD technologies and the geospatial, particularly Esri and their new utility network model. And so we've been working real closely with Esri. Right now we're exchanging 3D components with Esri and building the topology, that physical network is something we're already doing also. We just haven't extended it to the specific substation domain and doing all the transformation to show, a schematic or partially schematic representation as opposed to geographic representation. So again, it's very exciting that you guys are on this, because we've had this in our vision for a long time. And so this isn't, again, a big leap in terms of what we can do to take it to the next level.
Right. Yep. This is literally, to me, the next logical step that we need to take. We just have to be brave enough to take it.
Yeah.
Sean, this is Mark. This is reminding me of 20 years ago when we went to our GIS system, and ESRI didn't have a global ID yet. Each feature class, poles, transformers, switches, each started with their own global ID, but they didn't have one that crossed over all the features, and so we had to create a global ID generator. Well, now that's all caught up. That's kind of inherent to ESRI products now, but that's allowed our operations folks, once there's a GISM number that they're tied to a meter, and that goes to the transformer, and then we have, customer names can change, and all sorts of things can change. But people that don't even do graphical data maintenance are keeping our GIS data kind of up to date, because they're just keying off of that global ID and their associated records. And so to me, this is the next generation. So now we're going to pour that into the design concept also. Yeah, makes tons of sense. Can't wait till you solve it.
So I got a question. This came up in a demo that was done with this earlier this week. The question always is how from here. A very small percentage of substations that are modeled in 3D. So the question I have is, can this be adapted to use point cloud? So you could go out and do a LiDAR scan, for instance, and use that and attach your sensor data to it.
Yes. The point cloud data and the stuff that comes in, I want to say Forge directly interprets it, and if Forge doesn't, then you can pull it into Navis and then dump it in there. And,
yeah, it does, Sean. It'll read it in directly.
Okay.
Yeah. New stuff.
Yeah, because
I think that would be a good demo to as far as a next step, because the value there is you don't have to wait for all the substations to be modeled in 3D to get the visualization portion of this.
Yeah, so that was a question that I asked one of the operations people directly. And, you know, the operations folks were like, man, when can we get this? What can we do with it? You know, how soon can we have it? And then I was asking another question of, you know, how many stations do you have modeled? And, you know, my answer was, well, you know, we have a relatively low number of stations modeled today. But one of the things that, you know, is slowing it down is the level of detail required to actually do this kind of stuff. And so I asked them point blank, I was like, you know, we're looking at this transformer right here. This is a good looking transformer. This is a well modeled thing. But do you really need to count the number of sheds right there? And universally across the board, they said, no, you know, we just need to know that there's an insulator there. So, you know, for purposes of operations and maintenance, maybe not design, but for purposes of operations and maintenance, maybe a LiDAR scan is sufficient, right? We can get out there and we can do, you know, a scan with LiDAR and get the general shape, clean it up, make it look pretty good. And at least from the starting point of gathering data and using it, that might be good enough. So that's just something to think about, is like, you know, you don't have to have super high quality 3D models to get started in this. That doesn't mean that we don't want super high quality 3D models. We absolutely do. But that shouldn't be the sticking point for starting in this space, right? Because there's plenty of other technologies that'll give us a starting point. And quite frankly, if we can get people interested in it, if we can get operations and maintenance interested in it, then the money to do the modeling is going to come to us.
When you do a LiDAR scan, when you're talking about getting that point cloud, do you need to make each of the piece of equipment a single entity? Do you need to change that to where you click on it and it recognizes that, you know, at the connector level it changes, you know, and you know, the point cloud I'm thinking about is it's all just one kind of big blob.
Yeah.
And do you have to go through and modify that, or with these tags does it matter if it's a single entity?
With the sensors, it doesn't matter. With this particular architecture, it really doesn't matter, because this particular architecture simply builds on the fact that, hey, I've got a thing and that thing's got a tag on it. And it's really the information that's on the tag that tells me everything about it, right? So let me kind of show you what I'm talking about here. Let me zoom out and let me do a top and scooch down here. Let me select that guy, and I'm going to hide the roof of that guy and show you, you know, this sensor was really just mean to line up with this battery bank right here to show you the battery temperature, right? So it doesn't have to be actually attached to the battery. We just need to know that there are some batteries there for this particular architecture. Now, if we get into a more detailed world where we're using SIM and we want to use global identifiers and whatnot, we would indeed need to have each one of these pieces of equipment identified separately. It still doesn't have to be at a huge level of detail, but it needs to be at enough detail so that we can identify that, yes, that's a transformer. Yes, it's a breaker. Yes, it's a regulator. And this is the asset tag for it. Make sense?
Yeah, that makes sense. And like you're saying, once you tie it into something like SIM, then that would be a different thought process around setting that model up.
Right.
That makes sense. Mm-hmm.
Another cool thing I wanted to show you guys is I actually have this model also in BIM 360. And one of the next steps I want to do, and where we want to go, is we want to take this guy and we want to tie it into BIM 360. So such that, you know, this model here, I've got it living over here, and I've got some issues on this model. You see, it's the same model, and I've got some issues in BIM 360. I'm going to click over here. And this issue was something I reported that said, hey, this is an 18-inch pipe. And it seems to me that that might be undersized for this particular substation. So maybe we need to, get with civil, talk about getting the head wall sized up, something like that. I can pull this issue data into that model, or better yet, I can link the two together somehow so that if I'm over here and I'm over here, I'm looking at the same thing. Yeah. So I don't want to have to go between two systems. I'd rather have my issues in here, maybe over here, or I'd rather have my sensor data in BIM 360, one of the two. And once again, the cool thing about it is this being web technologies and using the Forge API, I can do either or. It really just depends on what I want to do and how I want to do it. Does that make sense?
Yeah, well said, John.
The good thing about that is for those utility companies that are not quite there yet with cloud, right? We're not quite to the point where we're really trusting in cloud. You can do something like this and it can all be on-prem. The processing and the general stuff, that doesn't have to be in the cloud. It doesn't have to use Azure. It can use internal resources. Remember, this is all just HTML and JavaScript in a browser, and you can certainly host it on a web server inside your place of business. So it's really up to you and your comfort level, but the use of the cloud isn't really a stopping or a starting point in regards to the use of BIM. BIM can be done internal just as easy as it can be done external in the cloud. It's really the one place where I put my data and use my data.
That's awesome, Sean. It's funny, like working on this with you in the front end, that we have been experimenting with those frameworks, the web frameworks with our utility content site for so long. And I think we just barely scratching the surface here. And I know, you put this together very fast too. So I think you're just getting started. And I think Ron mentioned earlier, like having it push notifications to mobile and all that cool stuff, which is really, really going to be phenomenal. And, I find it odd that Big Chungus was actually my nickname in high school. So that's pretty.
Actually not that's actually a term that my kids use often, and it just seemed appropriate for the substation for some reason. But it's good to know that that's what they called you as well. Yes, the Forge viewer can absolutely be hosted on-prem. The Forge viewer is literally just a JavaScript file that you pull into a browser. It is not based on it's not in the cloud at all.
Yeah, Sean, I guess it's worth noting that, some of the viewer stuff we did, that format that you end up with, that SBF format, as you said, to have it on premise, you can run it through Forge and extract that file and have that file local as well and load it into that same browser and everything, right? So totally on premise after the transformation to the SBF file.
Yep. And what you also get, this is something I didn't show you guys. So for this particular guy right here, when I put them out here, all of the I properties for the inventor assembly, they follow right along with it. So this is in the browser in prem. I can get to my I properties and whatnot and see, data that's in Vault. So these came out of Vault, put them in the cloud. All of my properties that are in Vault follow it. So if, on the SOCO side, we have several integrations in Vault that call into systems of record, like our, material management system, our project management system, our estimating system, all of that kind of stuff. We call into Vault to get that data. We put it in properties on our models, and that data can follow it. So that data is actually embedded in this file format. It's called SVF, and we can get to it and use that data for other things, right? So if I've got a global ID, I'm going to keep kind of harping on that. If I've got a global ID that says that transformer is, 1, 2, 3, 4, 7, 8, 9, 10, then, it's 1, 2, 3, 4, 7, 8, 9, 10 in my project management system as well, and I can link right to it.
Hey, Sean, we got another question here.
Java licensing costs? The answer is no. This isn't Java, this is JavaScript, and it's free. All of this stuff is just part of the Forge API. So if you're paying for Forge, and a lot of the Forge components are actually very cheap or free. The viewer isn't really charged for, in my understanding. The viewer just shows the SBF files that are converted from your models as part of the model derivative API. The model derivative API can cost money, but that's a fairly modest cost. I can actually show you, well, I don't know if I can. I've been hosting this website for several weeks on Azure, and as a developer at Southern Company, we get a certain allotment of credit to do Azure stuff as part of our license for Microsoft. And I get $150 a month credit on Azure to do this kind of stuff. And I've used maybe 20 bucks over the last three weeks or so of me doing this. So this has really been a very cost efficient thing. And I've used, I think, no Forge credits because what I'm doing doesn't fall into a cost bucket for Forge because my transformations are not one of the bigger transformations. So I'm not transforming a Revit model. I'm not transforming a Navisworks model. These are inventor assemblies, and those fall in the low to no cost transformation bucket. Now, don't let me lie to you. Certainly talk to your Autodesk rep if you want to start looking at how much something like this would cost. But I can tell you from my experience thus far, it's been very cheap.
So the Forge credits only come into play when you're transforming something to be used in the viewer to be a SVS file?
Correct. So, and it really depends on what you're transforming, right? If Navisworks and Revit models, they have a cost with the model derivative API. Trevor, I'm certain, can talk to you about some of the other stuff, the configuration, what's that?
Design automation?
Yeah, the design automation API. That design automation API has a cost.
Yeah. See, I mean, you can basically run Inventor in the cloud or Revit in the cloud. And they call it design automation for Revit or Inventor. So those take credits. You're basically running a full non-graphical version of Inventor or Revit or 3D Max. But really the credits are so minuscule. We've been transferring massive stations like this, like as far as Inventor goes, it's a very large assembly. But the Forge credits are like, 0.018 credits, which is, 1 credit is 1 full hour of processing time. So to convert like a small substation assembly, it was 0.018 credits. So, I think it's like $100 per hour or per 100 credits, for Forge, if you're actually buying them flat out like us as a partner. So it's very, very, very tiny for the stuff that we're doing. If you had 5,000 people building substations and transferring them into different file formats online, the price would probably climb. But for what we're doing, it's pretty small.
Yep. And I did look at one time, and I know that Autodesk had an enterprise level Forge license where you could buy more than 100 credits at a time. You could buy a whole slot of them. I don't know if there's any Autodesk rep that could verify or disavow that currently on this particular call, but there's some stuff to work through there.
Yeah, I've seen some of the offers, Sean, with like 5,000 credits or something, but kind of crazy for what we're doing.
Yeah, but I mean, quite frankly, if you look at this and actually think of the value add for something like this, the cost is really insignificant, right? Think about the value you get from having everybody in the chain doing all their work from this model, regardless of where you're at. If I'm standing in the substation next to the transformer, or I'm all the way back in the office and I'm looking at my, if I'm looking at my material management system and I'm looking at my single lines and and everybody's always on the same page and everybody's looking at the same thing, think of the cost savings right there. Think of how much time you saved, and then take all that money that you throw in Forge and compare it. And I think that you would be still, well within, I don't even think the two numbers would line up right. I don't even think you could compare the two, because it would be so minuscule versus the cost savings. It would be ridiculous.
Yeah. Yeah. And like you touched on it earlier, Sean, like for all us old school tech guys, I mean, it's pretty amazing to write, one code base as you and I did here, and it'll run everywhere. And as you test it, I was as blown away as you were when we started doing our utility content site. The fact that it'll run, on an iPad, Android, Linux machine, you get the same front end, same interface. It just blows me away on how much easier it is today.
Yeah, I'm going to post it out here again, and I challenge you all to go out here and try it.
Your phone was ringing over and over again. That might be Microsoft calling you.
Yeah, pull it up on your iPhone and mess around out there. You're going to see it's going to work. I mean, it's going to be a little difficult to stare at on an iPhone, but it's going to work.
Hey, I had a quick question for Trevor, and this is probably off of the main topic, but still has to do with Forge. And I know that we've been working on converting from MicroStation to Inventor. Taking a MicroStation model, converting. Does it do Inventor back to MicroStation?
Well, that's a good question, Ron. Yeah, I suppose it would. Yeah, I mean, the conversion it went really well. I think the models came through quite nicely. We were able to run Inventor in the cloud to kind of pull it together as an assembly. So yeah, we could try the other way around, I'm sure.
Yeah, because one thing that we're struggling a little bit is, of course, we've been using MicroStation for years and years. We're probably more than 20 years, and so now it's going to be incremental steps going from MicroStation to Inventor. Is not going to just be all at once. Everybody converge. So now we're thinking and maybe some of you guys already did it, where we're thinking let's start creating our standards in Inventor, so that we only have to create them one time and we only support them one time, and then convert them back to MicroStation so we don't have to draw it twice. And it certainly eliminates some of the resources needed. But I don't know if anybody's done that, or if you guys have tried it. Or
yeah, we could definitely we could definitely try that, Ron. Put it into a DGN file. I don't see why it wouldn't turn out. As always, what metadata is still there, and how useful is it? I'm not sure, but we can try it. We can try it pretty quick.
Okay.
Yeah.
Thanks.
Yeah, no problem. I don't know if there's any other questions, Sean. I don't see anything coming in there. Anybody got anything they want to? We're coming up on the end of the hour, but does anybody have anything they want to go over? Yeah, Sean, you did such a good job. Hey, if that server is still up tomorrow, I'm going to be really impressed.
Yeah. Well, if that server's still up tomorrow, then that's going to speak to the other thing that I wanted to talk about. We talk about fear of the cloud and whatnot, and I challenge you guys to think, within your utility, and think about what we do, right? Utility companies, we're kind of engineering companies that do IT to support, engineering. I challenge you to think that is your internal IT group who does, IT to support engineering any better at securing cloud resources and, big data than somebody like a Microsoft or a Amazon that does this, as their bread and butter business? Now, I got to think that, a Microsoft or a AWS, those guys know how to secure this stuff in the cloud a lot better than we know how to secure it inside our network. I said it yesterday during a meeting, at any point in time, we're really just one firewall away from a breach in any utility company. You know, it only takes one person to kick over our firewall and all our stuff is out there anyway. So wouldn't it be better to have, you know, a Microsoft or an Amazon, somebody who does this, you know, have our back on it? So that, you know, that's just my argument for fear of going to the cloud. I think they can do it better than we can, to be honest.
Sean, there's so much truth in bumper stickers. I think you came up with a favorite. One firewall away from a breach. All right, we're gonna shut her down. Mike, do you wanna add anything, or you wanna close out with anything? You guys go ahead.
No, great presentation. Fantastic. I have nothing to add.
All right, John, you want to close out with anything?
I don't have any words of wisdom or anything. I just, I'm very glad that you guys gave us the opportunity to show you guys what we're doing. I'd like for you to, you know, keep an open mind and really think about this. You know, I put that website out there so you guys can poke around at it, mainly so that you could give us ideas. You know, send us emails, talk to us, tell us, hey, what about this? Can we do this? Can we do that? Let us know. And if we can do it, we'll give it a shot. And if we can't, we'll tell you.
Yeah, great point, man. It's been a lot of fun working with you, Sean, on this, as always, the last decade or so. But this has been a lot of fun for us. I think there's been new technologies we really wanted to push. So yeah, now that we've got all the framework in place, let's try a bunch of things. Awesome. Well, thanks for joining, everybody.
Yeah, thanks, Sean. Great job.
Thank you all.
Yeah, thanks, Sean. Thanks
Thanks,
a lot,
everyone.
Mike.
Very good. Good job. Thanks, guys.